Good morning and good afternoon to all of our participants. Thank you so much for joining us. It's my great pleasure to welcome you to today's webinar on renewable energy in the manufacturing sector. For those of you not familiar with IRENA, we're an intergovernmental agency mandated by countries around the world to promote the widespread and sustainable use of all forms of renewable energy. IRENA has 139 members and more than 35 states in the process of becoming members. Today's webinar will launch the in-depth study conducted by IRENA to assess the technological and economic potential for renewable energy in manufacturing up to the year 2030. Our speakers will be discussing 6 priority areas that warrant action from policymakers and industry stakeholders, as well as sharing 3 real-world case studies. Before we begin, we'd like to share a quick note that IRENA does not endorse or recommend specific products or services shared within its webinar series. Information in this webinar is featured in the IRENA Renewable Energy Learning Partnership database as just one of many best practice case studies. If you are interested in finding out about future webinars offered through the IRENA webinar series, please visit the IRENA Renewable Energy Learning Partnership website and sign up for our weekly newsletter to receive updates on courses, webinars, and internship opportunities in the sector. For today's webinar, we have 2 options for listening in. You may connect by computer by selecting mic and speakers, or by phone by selecting the telephone option in the right-hand panel. If you should face any technical difficulties during the webinar, please contact the GoToWebinar help desk at the number provided on your screen. I would like to encourage everyone to participate in today's session by asking questions. To do so, simply select the questions panel in the right-hand bar and enter your question with a note of who you would like it directed to. We will be collecting questions throughout the webinar. If you would like to watch this webinar again or to share it with a friend, we will have a full recording available on the IRELP website as well as on the IRENA YouTube channel. If we are not able to answer all of your questions during today's session and you wish to connect with our panelists, I encourage you to visit the IRENA community and join the renewable energy in the manufacturing sector discussion under featured topics. So without further ado, I would like to introduce our panelists for today. Our first speaker will be my colleague, Dr. Ruud Kempenaar, who is IRENA's Technology Roadmap Analyst, responsible for the development of IRENA's technology roadmaps. Before joining IRENA, Ruud was a research fellow at the Harvard Kennedy School of Government, before which he was a postdoctoral fellow at the University of Sussex. Second, we will hear from Dr. Peter Botchek, who has served since 2006 as the Director of Energy, Health, Safety and Environment at the European Chemical Industry Council. Before joining the Council in 2001, Peter worked for the European Fertilizer Manufacturers Association in Brussels as an issue manager for agriculture and environment. We are also joined today by Mr. Abhishek Batuwara, who is the Director of Clique Solar in Mumbai. Clique Solar is India's first solar boiler company, which helps commercial and residential customers meet their heating and cooling needs with solar thermal technologies. Prior to joining Clique Solar, Abhishek worked for Rohan Builders India, a leading company in real estate development, industrial contracting, and infrastructure development in India. And lastly, we will hear from Dr. Linus Smofor, who is a senior energy and climate change expert for the United Nations Economic Commission of Africa. Prior to joining UNECA, Linus worked for the International Renewable Energy Agency as an innovation and technology analyst. I hope you all enjoy the webinar, and with that, I would like to hand the floor to our first speaker, Ruud. Ruud, you have the floor now.
Good day, everyone. My name is Ruud Kempenaar, and I want to start off by actually introducing my colleague, De Saigen, who is also the co-author of this study and is here with me in my office. And when asked to organize this webinar, we as analysts had to come up with a catchy title, which is a little bit difficult for us. But we gave it a try and we came up with The Next Frontier. And we believe that refers to 2 things. First, there's a lot of developments in technology which have been taking place in the last couple of years, and renewable energy technologies, both for power and heat applications, are now becoming increasingly cost competitive. So we're really looking at a new era. And secondly, it also kind of refers to exploration. Renewable energy power generation has been taking place and is growing very rapidly, but we haven't touched as much the industry sector yet. So now the question is, how can we move into this next frontier? How can we conquer the world with renewables also in the industry sector? Let me first start by giving you some background. This work stems from a project called Remap 2030, in which we looked at how we can double the share of renewable energy globally by 2030. What we did in this project is to look at 26 countries around the world. And these 26 countries are indicated here in blue. And they account for about 75% of global energy demand. The results show that if these countries implement their existing renewable energy plans up to 2030, then the share of renewables would increase from 18 to 21%. So that means we're still 15% shy from reaching a doubling, which would then be about 36% in 2030. We also calculated the costs of what this would mean. Then the next step, what we did is we asked in each one of those countries national experts about what are the additional potentials for renewable energy technologies, and we then calculated those costs. What we realized then was that if you calculate those costs, you can actually double the share of renewable energy globally in a cost-competitive manner. The orange circles here indicate where these potentials for renewable energy deployment lie. They lie interestingly, in areas where you also have a lot of manufacturing. So in China, in the US, and in Europe. So looking at the manufacturing sector in more detail, we can here see the breakdown globally of energy consumption. And the industry sector accounts for about 1/3 of global energy consumption. Around 60% of this energy consumption lies actually in non-OECD countries. So this is outside of Japan, Europe, and North America. For example, China accounts for about 30% of energy demand globally in the industry sector. Another interesting factor is that 70% of the energy consumption in the industry sector comes from process heat, another 20% from electricity, and then around 12% which is used is oil, which is used as a feedstock to produce mostly chemicals. If you break that 30% of energy consumption further down, you can see three big users of this energy. First, the iron and steel industry with 25%, then the chemical industry with about 13%, and then what is called the non-metallic minerals, and which is mainly cement, which is around 12%. Before continuing to the next slides, I briefly wanted to put these figures in perspective. So I just showed that global energy demand is around 380, say 400 exajoules globally. So if we're talking about 1 exajoule, and we'll talk about 1 exajoule in the next couple of slides, we're actually talking about a unit of energy consumption which is similar to the total energy consumption in a country like Austria. Now, the biggest consumer in the world is the United States, and they have around kind of 60 exajoules. So I'll refer to these exajoules in my next slides. So what came out of this analysis is really an analysis for the industry sector. Now, this slide shows the share of renewable energy in the industry sector in the 26 countries that we analyzed. So from left, you have the countries with the highest shares, to the right, the countries with the lowest share. Now, there are two important aspects to look at in this slide. First of all, the blue bars are the current share in each one of those countries, The red bars are the shares which would be achieved if they implement all of the national renewable energy plans. And the green bars are the share of renewable energy share which would be achieved when we implement all of the options identified by the national experts. Two important things to realize. First of all, except for Denmark and maybe France, many of the countries, the blue and the red bars are a similar height. Essentially, it means that there is little plans in the national energy plans which look at the industry sector. And the second important aspect is that the green bar is much higher than those two others. So there is significant potential to increase the share of renewable energy in many of these countries. So this also becomes evident if we look at it at the global sector. At the global sector, which is also in the middle, we see that around 8 to 9% of the renewable energy share. Sorry, we see that here, 8 to 9% of the renewable energy share is of the share in industry is renewable energies. If we include the renewable energy which is produced by renewable energy power sources, so for example, hydropower, electricity use, and aluminium smelters, the share would increase from 11% today to about 15% in 2030, according to national energy plans. However, if you look at the green columns, the potential for renewables in the industry sector could actually be doubled, especially on the heat side. So now the main question is, how could we realize this potential? And secondly, are there any additional potentials, or are the additional potentials identified by the national experts realistic? And so in the next couple of slides, I will give you some insights from a detailed study, which is available now, that we conducted to examine the renewable energy shares in the sector. First, let me talk a little bit about the methodology which we've used. The methodology consists of essentially 3 steps. First, we looked at the projections of industrial energy use between today and 2030. We broke that down into low, medium, and high temperature processes, electricity demand, but also demand for feedstock. So that's again the oil for chemicals. In this sector, we also, in this step, we also looked at the potential for energy efficiency and incorporated that into our analysis. So we found that if the industry follows best practices, we could kind of save around 40 extra joules of energy consumption by 2030. So this is kind of equivalent of the 40 Austrias, which I mentioned before. So 40 times the energy consumption in Austria. In the second step, we looked at the costs. So we looked at an assessment of what are the gas, oil, coal, and also biomass prices in 2030. Thirdly, we looked at the potentials of renewables. And again, we did that in 4 phases. So the first thing we did was that we looked at, for each individual renewable energy option, what is the technical potential. And so the technical potential, we identified what can be consumed in the, what can be producing low, medium, or high temperature, what can be implemented in existing factories, but also what could be integrated in factories which are going to be newly built between now and 2030. Based on that, we looked at the economic potential. So the economic potential is a subset of the technical potential, and there we compare the costs of the renewable energy options with the cost of conventional renewable energy technologies. An important factor, again, in the analysis of the economic potential is what, of course, the oil price is going to be in 2030, but also what would happen if you incorporate carbon pricing in your analysis. So we did a number of scenarios there to look at, okay, how would such policy instruments impact the economic potential of renewables in the manufacturing sector. In the third phase, and again that's a subsector of the economic potential, we looked at the economically realizable potential. And here we also incorporated the potential limitations of biomass availability for the industry sector. And then last but not least, we also looked, of course, at the allocation of the renewable energy options. Because, for example, for low temperature process demand in the industry sector, you could use geothermal, you could use solar thermal, or you could biomass. So in this last and fourth phase, we essentially look at the allocation of renewable energy options. And we did that by first looking at the cheapest options and the low temperature the deployment opportunities, and kind of work our way up. So what came out of this analysis for the industry sector? This kind of slide shows the overall results. As I discussed previously, we're mainly using biomass today, and the national experts identified already about 15 exajoules of additional renewable energy options in the industry sector. Now this detailed bottom-up analysis actually identifies that there are even further potential there. Another 2-3 exajoule if we take the most negative assumptions, so essentially meaning that the oil prices will be relatively low, there will be no carbon pricing, and biomass will be very restricted. But there could be another 11-12 exajoule, and again 11 or 12 times the energy consumption of Austria is available if we would have carbon pricing in place and biomass resources are available for the industry sector to use. So in the next couple of slides, I would like to break this kind of global results a little bit down. First, we quickly want to have a look at the results per technology. And so this shows the potential of the renewable energy technologies which are realizable. We looked at 4 renewable energy options: solar thermal, heat pumps, geothermal, and biomass. And then we looked if these technologies can be used for low, medium, or high temperature, and their potential in retrofit versus new capacity builds. So each one of those bars shows you different renewable energy technologies and in which energy sectors their potential lies. The graph shows that for biomass, and those are the highest bars over here, there is the largest potential. Even more than 6 exajoule of potential for biomass in high temperature applications, around 7 exajoule of biomass potential in medium temperature applications, around 6 exajoule of biomass in low temperature applications. Then there's another 2 exajoule of biomass potential to be used as feedstock for the production of plastics and other chemicals. Solar thermal capacity, another 2 exajoule of potential is available for low temperature heat, and especially in the buildings of new industry capacity. So essentially that means if you're building new factories, you could integrate these solar thermal technologies into the design of your factory and then use it. However, there's also about half an exajoule of solar thermal capacity of potential to retrofit it, essentially build it on top of existing industry plants. Geothermal, around 1 exajoule. Heat pump, if you combine it, also about 1 to 1.5 exajoule. So this kind of adds up to a lot of exajoules of potential. We also looked at the deployment of these technologies per region. So now you see the technologies are the colors, and the different bars are the different regions. And the 2 regions with the highest potential are North America and China. China, of course, is a big manufacturing hub, so there's a lot of energy demand over here, there. So that means there's also a lot of potential to use renewable energy technologies. In North America, there are many existing manufacturing plants, but quite a few of them come to the end of life in the next 10 to 20 years. So that means that if you're going to replace some of these factories, you can already start integrating renewables into the design of these factories to provide process heat. After my speech, we will have some presentations from representatives from India, Europe, and Africa. You see that each in one of those regions you have a potential to up to kind of 3 exajoule of renewable energy options in the industry sector. The other element to discuss in this particular graph is, of course, the color. And as you can see, and also as we explained in the previous one, a lot of the renewable energy options are biomass based. So that's all of the green, which we can see in this particular chart. We've also looked at in more detail in the potential for renewables to be a feedstock for the production of materials. So these materials could be plastics, but they're also being used to create fibers to produce clothes or bottles. Now, this is already happening today. And what these figures show, these are cost figures, show that actually the cost of producing bio-based ethylene, which is one of these feedstock products, is already competitive with fossil fuel-based ethylene production, especially in India and Latin America. And so production already is, for example, taking place in Brazil and India today. Another product is methanol, also one of these chemical commodities which is being used for many different kind of applications. And also there we see that slowly the costs for the production of bio-based methanol are coming in range with the cost of fossil fuel-based methanol. So there's a lot of opportunities there. And these are discussed in 2 separate kind of technology briefs, which IRENA produced in January 2013, which are also downloadable from our website. So what does it all look like if we add up all of these renewable energy options together? This is quite a complicated figure, but I'll try to explain it very simply. So on the x-axis, you have the renewable energy share in the industry sector, and on the y-axis, you have costs, the substitution costs. Essentially, what this y-axis means that any options above the 0 would be more expensive than if you would use conventional technologies, and any options below the 0 are cheaper than conventional technologies in 2030. Then you also see 3 kind of what we call cost supply curves. On the left-hand side, you see the gray line. This starts around, or each one of those graphs starts about 10%, which is the renewable energy share which we would be in 2030 if we only look at the national energy plans. And then the endpoint on the right-hand side shows where you would end up if you would deploy all options. So any time we talk about the economic realizable potential, we simply follow this line up to the point where it hits the 0. So up to the point where these renewable energy options are cost effective. Now if we assume there's going to be no carbon prices, that the oil price is going to be very low, and the biomass is mainly used for biofuel production in the transport sector or for the generation of electricity, you can see that the cost economic potential, and that's in the gray line, is only a couple of percentage points. Still, we're talking about exajoules then, but it's relatively limited. Now, if we look at the blue line, and that's the line if you have carbon pricing, high oil prices, and a lot of renewables available, or biomass available, you can see that there's an economic realizable potential to increase from 10% up to around 34%. So a big potential there. We've also tried to put some kind of technologies across this blue line, but you have to be aware that these are global averages. So what we've done over there is just simply look at the substitution cost of these technologies in each and one of these individual regions and averaged it out. So the sequence of these options might differ, or definitely differs per region and per country. So now that we know that there's a lot of potential for renewable energy in the industry sector, what shall we do? What should policymakers do? What should industry do? This analysis was combined with a number of workshops which we organized, for example in Brussels and one in India, where we also got from the industry experts and policymakers some qualitative insights in what is needed in this sector. And so we came up with 6 points, 6 areas where we think more action is needed to deploy renewables. One of those is in the energy-intensive sector. The energy-intensive sector, like the big chemical plants, they consume the majority of energy consumption in the industry sector, but there are only a limited number of those plants. So looking at how you can integrate renewable energy technologies in these plants will be able to address a lot of this potential. The second area where we think more work is needed is to look at the renewable energy potential in small and medium-sized enterprises. And there are 2 kind of important factors there. First of all, small and medium-sized enterprises account for about more than 90% of all industrial plants. So these are many, many small users. And by starting deploying renewable energy in this particular sector, you also create a lot of awareness about the possibilities. Secondly, there's a big potential there for what we call scalability. So if you design a renewable energy technology for a small textile plant somewhere, for example, in the south of India, that technology could be deployed in many other of these plants around the world. The third area where we think more work is needed is in biomass. As you saw, 80% of the renewable energy options in industry is in biomass, but we need to make sure that the biomass is available, but also sustainable. That means that we have the biomass available to the industry over longer periods of time without interfering with any food production or use of land. The fourth area is in solar thermal systems. We've recently launched some technology briefs on the potential of solar thermal for industrial applications, and in that technology brief, and it has been confirmed afterwards as well, we see that really there's a big shift in the last couple of years to new markets of these solar thermal applications in Latin America and in Asia. And we think that more deployment is needed and can be done in these sectors. The fifth area is electrification. The share of electricity in the industry sector is relatively low compared to heat demand. However, there are a couple of big processes, for example, the production of aluminium, which require a lot of electricity. So there's a big potential there, for example, to locate those aluminium plants next to hydropower plants. And the other area which you, for example, could think of, and this maybe further into the future, is this area of 3D printing, where you use actually electricity to produce products. Again, there's an option there where you can use renewable-based power to help the manufacturing sector. And then last but not least, I think it's very important to look at the regional aspects. How can renewable energy be deployed in China versus Africa versus Latin America? Each of one of those regions has a different characteristic. And I think by pulling the resources in these countries together, we can come up with innovative and effective policies to deploy renewables. So where does that leave us? This is our assessment of the opportunities of renewable energy in the industry sector. And you can download this report from our website, especially on the REMAP webpage, which is displayed over here. And then we have this detailed report, which is available, and we can share with you. So just send us an email, and we can share this report with you. We also realize that time is limited today, so please continue our discussion at the community, IRENA's community, which myself and Dega will be actively available to answer any of your questions. So with this, I want to close, and thank you very much.
Thanks very much, Ruud, for your presentation and introduction for the topic today. Now we'll be hearing from our next speaker, who is Peter. So Peter, you have the floor now.
Thank you very much. This is Peter Wojciech speaking from Brussels. Hello, everybody. I will share now my slides with you, and I found the presentation of Ruud very, very interesting. He mentioned the potential energy use, renewable energy use in the manufacturing industry, and the chemical industry is indeed one of the largest manufacturing industries worldwide. And if I may present our industry, I'm speaking for the European chemical industry, which consists of some 29,000 companies, most of which are small, medium-sized, but of course there are the big companies as well, employing in total some 1.2 million people. Some numbers on the financial results as well. The turnover is about 500 billion to the EU economy, so it's one of the heavyweights of European economy. And we are really energy intensive. When you look at the chemical industry globally, where we are consuming some 42 exajoules per year, accounting for roughly 10 to 13% of the global demand. And this is the fastest growing industry worldwide. The interesting element in talking about energy is that there are some 18 chemical building blocks that account for 80% of the energy demand of this sector. And that is why some of the building blocks have an average energy cost of about 50% of total manufacturing costs, but it can be up to 85%. So energy costs are enormously important for this sector. But the sector is also enormously important for any other manufacturing sector, so we can proudly claim that some 95% of all manufacturing is using our products in their products. Now, what I would highlight, having listened to Ruud before, of course, there is capacity in using more renewables in the chemical industry. However, we always look at it from an economic side as well. As I explained before, energy accounts for a large part of our production costs, so it has to be competitive. And all the potentials that Ruud has presented, well, I have really the question to Ruud and to others in this call: is this really realizable? Is it realistic? When we talk about availability of biomass, for instance, are we talking about biomass manufactured or produced in the vicinity of this country that we look at, of the region that we look at, or is it? Are we trading here globally? Are we assuming that lots of imports are happening? That would be necessary in the case of Europe. The graph I show you here is that of the use of biomaterials in the process and in the chemical industry as such, and the shape of the arrows show the size of the inputs of these raw materials in the chemical industry. So lots is coming from refineries, inorganics, from natural gas, coal mining, and there is a thinner arrow that indicates bio-based materials. What I want to show is there is, of course, a recommendation that we should not use this feedstock input in a different way and thereby remove it from that use by burning it and using it energetically. So there is a competition between the uses of biomaterials, renewable materials in the chemical industry, either using as feedstock as indicated in this graph, or as energy source, you can not use it for both purposes at the same time. So you have to make a decision, and this has to be, of course, economically viable. The next slide shows you, well, what kind of bio-based products we have in the value chain in agriculture, transportation, and so on, in manufacturing, recycling. There is lots of uses of bio-based products in our sector. There are also key challenges when we talk about the use of these bio-based raw materials. Again, the challenge that there is competition between the use as an energy source in comparison to using it as a raw material. There is the issue of cost competitiveness, which I mentioned before. And there is, as Ruud also indicated, there is a challenge to integrate these products, these materials into current processes. You mentioned retrofit opportunities. The way I am aware that this is enormously expensive, so ideally you talk about new capacities. Again, there is a challenge in Europe because new capacities are being built currently to a large extent outside of Europe, namely in the US and in China and in other parts, Middle East, other parts of the world. So then there is a challenge where materials fight for higher value streams, where we are exposed to market forces. And indeed, I can support Ruud by stressing what industry needs is a stable, coherent, predictable framework, a regulatory framework, which makes investment feasible. And indeed, investments are needed, also in the European chemical industry, to make use of renewables, either as energy source or as feedstock source. I think I will end here, and I will leave the slides with IRENA to make use of them as they see fit, and I will be happy to answer questions and contribute further. Thank you very much. I hope you could understand me well.
Thank you very much, Peter, for your presentation. And next we will be hearing from Abhishek. So Abhishek, you have the floor now.
Good morning and good afternoon, everyone. My name is Abhishek Bhatewara. I am director at Click Solar. We are pioneers in the use of solar concentrator technologies in industries in India. Over the next 10 minutes, I will talk to you about the use of solar thermal systems in industries. I will broadly cover the various technologies in existence, the applications, cover a few case studies of our installations, some discussion on the economics, and the barriers we are seeing for its widespread adoption. So let's begin. A large part of the energy consumed by any society is attributable to the industrial sector. The figures shown here are for India. These will vary by country, but the story will remain the same. This energy is in the form of electrical and thermal. In the industrial context, majority of the energy is in the form of heat or thermal energy, which is required in the various manufacturing processes. Up till now, this thermal energy has been provided by burning coal or various forms of biomass, or in many cases by burning oil products. Each of these sources have their own limitations due to either the environmental impact they have, or their availability, or increasing cost. Solar technologies have been technically and commercially proven to provide this thermal energy and can play a significant role in reducing the dependence on these conventional sources. This chart shows the various solar thermal technologies that are in existence. These technologies can be broadly classified into two categories, depending upon whether they are concentrating or non-concentrating. The tracking technologies can be further classified based on whether they are tracking the sun on just east-west or both east-west and north-south direction. The efficiency of the system increases as you go from top to bottom. This slide shows the various applications that are possible by use of solar thermal technologies. Many industries like pharma, textile, chemical, paper and pulp, food processing, automobile, hospitality, etc. require thermal energy in the form of either hot water, steam, hot oil, or hot air, which can all be served by these solar thermal technologies. Cooling is another application of the technology, which has the potential of becoming a game changer for this industry. Due to the large number of religious places and education institutions, mass cooking has been the most prevalent application of concentrated solar thermal in India. This slide shows how a solar concentrator technology integrates with a boiler or a heater that is already in use in a manufacturing plant. This is the existing setup. Now, this is how solar gets integrated. This is just one of the possibilities, but the simplest way to integrate, where steam from solar gets mixed with the steam from the conventional boiler in the boiler header with the help of some controls. This also shows that solar is only an add-on and cannot be a complete replacement to the conventional boilers. A common constraint in solar is where demand for energy doesn't match the supply. Mass cooking is a very typical example. In such cases, short-term storage can be provided. I will not go through the schematic in detail as it is available for you for view later. Here are some examples of installations that we have done. This is an installation at a dairy where steam is supplied for milk pasteurization process. This installation is for one of the leading auto manufacturers in India for heat energy required for their degreasing process. This is installed at a 5-star hotel in New Delhi for energy required for laundry, cooking, and hot water for hotel guests for bathing. This is for NTPC for comfort cooling at one of their office spaces. And this one is at one of the more revered religious places in India for mass cooking for the devotees' food. This slide shows the cost of solar thermal concentrators. It ranges between 200 USD per kW to 2000 USD per kW. However, when you decide on the technology, the decision should not be taken on cost per unit of energy. It should be taken rather on the cost per unit of energy and not on the power. That is, cost per kWh and not on cost per kW. Although solar thermal technologies have been in existence for over a decade now, the adoption has not been very widespread. The barriers range from lack of awareness amongst top management, which are the decision makers, to the lack of standardization of materials and components, resulting in a very poor ecosystem. Space requirement to cater to a meaningful percentage of energy consumption is quite high. The initial investment is high and the payback periods are still longer than what industries expect. Lastly, it is still a government incentive dependent industry, at least in India. Government policies play an important role in proliferation of these technologies, and some of the policies become a hindrance rather than promoting the sector. I'll end my presentation here. Happy to take any questions later in the webinar or even after that. My coordinates are as displayed. Thank you for listening patiently. I hope I was able to give you some insight on the topic. Thank you.
Thank you very much, Abhishek, for your presentation. And so now we will hand over to our last speaker, Linus. And just a reminder that we're taking questions now, and after Linus's presentation, we'll open the floor to answer those questions. So Linus, you can go ahead.
All right, good afternoon, good morning, good evening, everybody. My name is Linus Mofo. I'm the Senior Energy and Climate Change Officer at the Africa Climate Policy Center 8, the UN Economic Commission for Africa here in Addis Ababa, in Ethiopia. So I want to follow up what my colleagues have said and looking at one of the priority areas where we can have policy support, and that is in the area of productive uses of renewable energy in Africa. I will quickly introduce you to what our organization is all about. Then I will talk about what is happening with renewables for productive uses in Africa, and then talk about opportunities going forward, especially in view of the structural transformation agenda that is ongoing in Africa, and then conclude with some key messages. So the UN Economic Commission for Africa is the only UN institution that is mandated to operate throughout the continent to harness the continent's resources and bring them to bear on the continent's priorities. The UNECA champions African structural transformation and green growth agenda because, as you know, Africa's economy depends strongly on raw materials, which are mainly exported. The structural transformation agenda wants to promote value addition in the continent, and that needs a lot of energy. And when you bring about a green growth, it means we need more low carbon energy sources to achieve structural transformation in Africa. The institution has got various divisions, including the one that I am in, called the Special Initiatives Division. This division also has some relevant centers like the AMDC, the African Minerals Development Center, the New Technology and Innovation Center, and the Green Economy and Natural Resources Center. These are all very relevant centers as they directly work on how we do low carbon green growth in the structural transformation. So if we look at what is happening with energy for productive uses in Africa at the moment, I refer you to the IEA's Africa Energy Outlook 2014, and you see that the energy use in Africa is very, very small. It's 142 million tons of oil equivalent, that's about 5 exajoules. And in sub-Saharan Africa, it is even smaller, when most of that is based in South Africa and a little bit in West Africa. But the agricultural sector employs a lot of people in Africa, and you can see that the energy used there for productive uses is very small compared to, for example, the services sector, mainly the telecoms. So there's a huge potential to achieve energy for productive uses in the agricultural sector in Africa. So some examples of energy use and the potential for renewable energy substitution. This is based on work that we did when I was in IRENA on renewable energy for productive uses in Africa, and the full report will be available in the next few months on the IRENA website. For example, cement production is a huge energy consumption area in Africa, but there is potential to go up to 50% or even more. Some companies are using large hydro, and this type of sector would actually function more on grid-connected large hydro systems. Similarly, for aluminum, again, very high energy consumption. Say, for example, in South Africa and Nigeria, the main energy sources are coal and gas. In Cameroon, for example, is hydropower. And again, there's a huge potential there for substituting the fossil fuel sources with renewables. But there's very little potential for small-scale upgrade renewables. And again, biomass, as Ruud mentioned in his presentation, is very, very important. He mentioned about the availability of biomass. In Africa, we have plenty of biomass, so there's a huge potential on how we can sustainably use biomass in industry. And for sugar, tea, coffee, and so on in the agro sector, again, huge opportunities for use of biomass, especially residues, bagasse, and biofuels. As an example of such a situation, we have a company in Kenya that produces 60% of the sugar in the country. It produces all of its energy from its Bagasse. It exports 25 megawatts into the national grid. And so it shows a business case of how companies in Africa can use renewables for productive uses. Ruud mentioned the issue about replication. This is a clear example of how much replication can happen here. As I said before, Africa's economy depends hugely on the agro sector. So there's a huge potential for renewables, for productive uses, and a huge potential for replication. So going forward, the African Structural Transformation Agenda is going to drive how renewables are deployed in the continent, particularly in the industrial sector, because as I said, the continent is now trying to push for value addition in the case of mining, in the case of agro-processing, but also there are opportunities for energy efficiency improvements in industry, but the awareness needs to be promoted, and policymakers need to make the right policies and bring incentives so that we can mainstream low carbon. In fact, the UNECA, our organization, in the Mineral Development Center is already developing regulatory framework guidelines for countries, how they can mainstream low carbon in the mining sector. So over a period of time, this will become a requirement, and so huge opportunities exist in this area. But across Africa, there are huge, as I said, huge opportunities which are still not yet being tapped, and therefore the opportunity for replication and scale up are really, really huge. Peter mentioned in his discussion about the lack of access to residues. In the concept that Ruud was presenting, there was a huge assumption on whether there will be availability of the biomass. In Africa, we don't have that problem, so we have huge opportunities for renewables in industry and for productive uses. So to conclude, there is a large potential in Africa for productive renewable energy for productive uses. We saw the number earlier, 5 exajoules of total energy. The share of renewables there is very small, but the potential is very high. But we have issues of data. We have to figure out how to better capture the data situation in Africa. So Ruud talked about the REMAP project, and the UNECA is going to be collaborating with IRENA to scale up REMAP analysis in Africa, and that will help us, together with our statistics division, to improve the data situation so that we can better optimize the opportunities of using renewables in industry in the continent. But it's also that the few heavy industries that we have would obviously always depend on grid-connected hydro resources, again, of which there are many in Africa, and an IRENA initiative which is called the Clean Energy Corridor. We have other initiatives, the Africa Power Vision, that is promoting renewables. If we were able to tap our renewable resources, then Africa's industry can be powered almost entirely from renewable sources, and therefore achieving the green economy drive that African governments are pushing for now. But the government needs to provide the right framework, the right incentives, so that these initiatives can take place, and also that the business opportunities can develop in scaling up the opportunities that are there but are not being utilized. So, so as I said, the main sector there would be in the agro sector and the mineral sector. And I thank you for listening, and I look forward to receiving further questions from you and the discussions later. Thank you.
Thank you so much, Linus. So that concludes our presentations, and now we're going to open the floor for questions. So our first question goes to Ruud and Dagger, and this was a question specific to one of your slides, which was showing economic evaluation. So Jonathan from our audience was wondering why solar thermal is showing as so expensive. So Ruud, you have the floor.
Thank you very much, Stephanie. My name is Dagger Saigen, and I'm working at the IRENA REMAP project. I would like to first of all start with putting these costs into perspective a little bit based on that slide which my colleague Ruud has shown. Solar thermal is indeed one of the expensive technologies. Its substitution cost in 2030 we estimated about $2 to $3 per gigajoule. And I would like to compare that first of all to the estimated 2030 fossil fuel-based steam generation costs. And our estimates show that based on the any fossil fuel price growth between 2010 and 2030, that by 2030 the steam generation cost would be about $20 a gigajoule. So the additional substitution cost from this technology from solar thermal in low temperature heat generation would be about 10% of the total. And that's the cost part of the discussion. But I would like to look a little bit on the recent developments and how the solar thermal in industrial applications has evolved in the past years. The technology has indeed started in Europe mainly, and then it has expanded in several countries. In particular India and Mexico, with a lot of promising applications in food, in some chemical industry sectors. But as also we showed in the analysis, these countries are of course large energy users, but there is a lot of global energy use in industry sector which is still to be covered by solar thermal heat applications. So the potential is high. There's a big gap to be closed, and that actually makes the industrial solar thermal heat more expensive than the other renewable energy technologies today. However, as I mentioned, there's a large potential to be closed by 2030, and there is that potential. If that is closed, there's also large reductions in capital cost through technological learning. And we show that actually if these economic potentials, realizable potentials by 2030 are taken into account, there is in gigawatts about 450 to 800 gigawatts economic potential worldwide for solar thermal heat industry applications. And when you compare that to the current installed capacity in building sector for solar thermal heat, that's more than 2 times. Today we have about 300 gigawatts solar thermal heat in the building sector. So there's a lot of potential. There is indeed the cost issue, but there is also the potential to reduce that, and that's also the reason why we identified solar thermal in this roadmap as one of the 6 priority areas to be looked into by the industry sector and by the policymakers.
Great, thank you so much for your answer, Dagger. So our next question goes to Linus. We have a participant wondering how developing countries can benefit from renewables to develop local industry. So Linus, you have the floor now.
Sorry, so how developing countries can use renewables to develop industry?
Correct.
Yes,
yes, that's correct.
Okay. Again, as I said, we need to have countries to put in place the right policies, because there are huge opportunities without looking into these fossil fuel sources. And many developing countries have got huge resources for renewable energy, and therefore the opportunities and the potential to leapfrog in terms of deployment into the long term is very, very high. So all the countries now need to do is have the right policies in place, have the right instruments in place to mitigate risk for investments and attract private sector. Because the private sector investments will be very important. And for industry, a lot of these industries are already private sector based. So the case for their economic improvements needs to be made so they can see how to optimize their revenues and increase profits and productivity, whilst contributing to low carbon development.
Okay, thanks very much, Linus. So our next question coming from Josha is for Abhishek. Josha is wondering how you solve spatial limitations of using solar thermal in industry. So Abhishek, you have the floor.
Sorry, can you just repeat that?
Sure, yes. So the question was, how do you solve the spatial limitations of using solar thermal in industry? Do you find that to be an issue?
Actually, that is one of the bigger challenges the industry faces, because most of the manufacturing industries are limited by the amount of space available. In our company, the way we are trying to overcome this issue is having a technology which stands on a single column. So if you have a look at some of the images of the Arun solar technology that we have developed, it stands on a column like an umbrella. So the footprint area that is required is is very less, almost just 3 meters by 3 meters for a 100 kilowatt system. The area in the air, because the area space required is obviously much larger, and again that becomes a limitation. But because it stands on a single column, you can have a large number of energy delivered by having these columns installed in very cramped spaces across the plant. Although it's not of the best possible solution, this is one of the ways that we're trying to overcome the solution. The other way is to actually have more improved efficiencies in the system, so that in a given area you would have more energy delivery, but obviously there is a limit to which this can be achieved. Hope this answers the question.
Great, thank you so much, Abhishek. So our next question goes to Ruud and to Dagger. Kareem is wondering how IRENA and other international entities can help to support the Moroccan integrated wind project, which is aiming to build 850 megawatts of wind with industrial integration. So if Ruud or Dagger could comment on that, please.
Of course. Such integrated renewable energy, renewable electricity generation projects on site of industrial facilities actually offer a number of benefits. One of them is supply security, and of course there's an important benefit on the cost side, in particular compared to the end use power prices. And so this is a very promising technology, a way of integrating renewable electricity generation with industrial applications. And such examples are actually now seen in other countries as well, such as in India. There's one example we know. Another recently was announced in the case of US. So there are plans of some countries, and there are others who are implementing this. So such best practices can help very much for countries that are in planning stage, but also considering such applications. So there is a lot of opportunity for knowledge sharing, for best practice information sharing and learning, and IRENA can be an important hub platform to facilitate such exchange of information. And coming back to one of the slides which Ruud has shown, there is the comparison of 26 countries' renewable energy share, and in the industry sector between 2010 and 2030. And one of the countries which we are very closely working with is Morocco. So we identified with the national experts of Morocco in the industry sector to have a potential in the industry sector of 15% renewable energy share by 2030 compared to the 2010 levels of about 5%. So I'm going to say at a bit of a higher level, not at the project level, at a higher level, at more sector level, we are, as IRENA, in collaboration through REMAP with various countries across the world in identifying the realistic potentials, their costs and benefits to 2030, and what can be realistically done also beyond. Thank you very much.
Great, thank you so much. So our next question goes to Abhishek, and maybe Ruud and Dagger can also comment if you would like. So this is sort of a technical question. Do you think that evacuated solar collectors can be effectively coupled with multiple effect distillation? So Abhishek, you have the floor now, and maybe we can hand it over to Ruud and Dagger after.
Sure. I'm not the best person to answer a very technical question, but I'll try my best. So as I understand, evacuated tube technologies coupled with, let's say, a parabolic trough are already in existence. And when you're talking about, I thought you're talking about multi-effect distillators. So the higher the pressure of the steam that you can get, the better the efficiency that you can get from a multi-effect distillator or an evaporator for that matter. Hence, any
Sorry for that delay. We just had some technical difficulties. So Abhishek, we'll give the floor back to you, and maybe if you can just repeat your answer there because we lost our connection. So Abhishek, you have the floor again. Sorry about that.
Sure. So I was saying that for distillation, you would use a multi-effect distillator, and to get the most efficiency out of a multi-effect distillator, you would want it to operate on multiple effects. And to get to use multiple effects, you need to have a solar technology that can get you to higher steam or hot water temperatures. Definitely, evacuated tubes related technologies in a solar trough context can give you higher pressures, and those are going to be helpful in driving a higher effect distillator. So as well as evacuated tube, there are the two-axis concentrating disc technologies which could also be used to get these higher steam pressures. But yes, evacuated tube based technologies can be used for distillation.
Great, thank you very much for your answer, Abhishek. Ruud or Degger, did you want to add there?
Yes, I just wanted to add some kind of global context to this question as well, which is within IRENA we also look at the opportunities to use renewable energy technologies and especially solar thermal technologies for the desalination of water. As you may know, many regions around the world lack water for consumption, and in most cases, or in a lot of cases, these multi-effect distillators are being used to produce water production. I just looked at the figures, and for example, for global desalinated water production, 8% comes from these multi-effect distillators, and about 26% from multi-stage flash distillations. Both indeed need kind of thermal energy to convert the kind of the salty water into potable water. And indeed, solar thermal technologies just in general, but also evacuated tube and specifically, can provide you with the temperature levels you need to drive these processes. So for multi-effect distillators, you need temperature levels which are above 70 degrees, so evacuated tube, but also other technologies, especially solar concentrators, as Abhishek said, can provide these temperature levels required to run these processes. And even for multi-stage flash, you need about 90 to 110 degrees centigrade. So there again, you can use these solar thermal technologies. And I think, just in the wider context, this is an important opportunity because to date, only 1% of energy demand for desalination projects comes from renewable energy. We see a big demand in this region, up to 9 to 10% capacities being added every single year. So using solar thermal technologies in these processes would be of great advantage.
Thank you very much. So our next question I'm going to direct to Peter, but maybe Ruud and Degger would like to add to this one as well. We have a participant wondering if there's any documented experience or best practices on how to work with the associations of end-user industries such as chemical or textile to increase renewable energy deployment. So Peter, you have the floor, and then maybe we can hand over to Ruud.
Thank you. We have no very recent study on the potential of renewable energy in our sector. What we have, of course, is an overview over the energy uses in our sector in general, and I can say that especially in the energy-intensive areas, the energy is required 24/7. So it is really high energy at a reliable pace coming into our plants, and that is not always, not with all renewables, of course, possible. The sun is not shining at night, as we all know, and the wind is also not always blowing. So there are limitations and challenges that we try to overcome. At the same time, of course, we have to look at the cost. A lot of the renewable energy growth in Europe in general has been enabled due to subsidies and preferential treatment of these technologies, also through carbon pricing. You might know that there is an emissions trading system operative in Europe, which makes renewables more attractive in comparison because of the carbon price. At the same time, we are now experiencing a relatively low price for oil, as we all know, which again is representing a challenge for renewables in Europe also. So there are lots of factors influencing the availability, but also the feasibility of using renewables in our sector. Again, energy intensive. We are depending on a very reliable flow of energy, and we are very capital intensive. So these very interesting examples we saw from in India or in Africa, of course, there you are benefiting to some extent from very reliable sunshine. This is also not the case everywhere in Europe, especially not where our biggest installations are. What the chemical industry has done to be more effective and efficient, we have so-called clusters. That means that there are a lot of different manufacturing streams integrated at one site, using the energy, also low temperature and heat flows and so on, to the least bit, to make it highly efficient and to use every bit of energy as much as possible. So that is why, despite even higher energy costs in relation to other parts of the world, many European producers are still competitive in many areas because of this super high efficiency that we have at our sites. That makes, in some cases, it makes introduction of renewable sources possible, but there are also limitations. Thank you.
Thank you very much, Peter. So now I'll open the floor to Ruud and Degger to see if you wanted to comment there, and we have another question for you, so we'll keep you on the line.
Okay, thank you very much, Stephanie. Now we think that kind of industry associations are crucial in the whole development of renewable energy and deployment of renewable energy technologies. We, as an intergovernmental organization, of course, work mostly with national governments. And national governments can set kind of the framework which will allow for the deployment of renewables. But at the end of the day, it's the industry, not only the energy consuming industry, but also the manufacturers, which are the ones which will have to deploy projects, and which are the ones which will take this transition towards renewables further. So working with associations is key. Now, as you see, as we've kind of explained, the Global Renewable Energy Roadmap, we work on a country-by-country basis. But what we've did in this particular roadmap, this manufacturing roadmap, we looked across countries. And I think that's where indeed the associations become very essential, because associations can pull together experts in a particular sector, like the chemical sector, from across multiple countries and bring together that knowledge of these countries and therefore accelerate the deployment of renewables. So like CIFIC is doing in Europe, but also other associations are doing in other regions, putting those experts together is crucial. And the way we engage with these associations is that we then ask them to come to workshops which we organize, stakeholder workshops, so that we get the best experts available to explain us exactly what are the opportunities, but also what are the challenges, and how can policy frameworks be adjusted or improved in order to get this deployment happening on the ground. I think another important area where you can work with associations is that many of these associations develop their own roadmaps internally, where they try to kind of get a sense of what is happening into the future. So as we are doing this at a global level, these associations are doing it at a sectoral level, and it's great to be able to kind of match these roadmaps to one another and to see also where responsibilities lie for further activities. And then the third and final point, I think, where associations are important also for IRENA, is that they have a lot of data. Just to give you an example, for example, small and medium-sized enterprises, as we mentioned, constitute of 90% of all industrial plants over there. These are a lot of people who have a lot of data, and for an intergovernmental organization, it's impossible to collect all that data. But through the associations of these industry clusters, we can get this aggregated data, which will allow us to make these global analysis happening. So I think from all sides, there's a very there's a lot of benefits to collaborate and to cooperate, such that we can make this renewable not only embedded in policy targets, but also into projects on the ground. Thank you.
Wonderful. Thank you so much, Ruud. So we'll keep you on the line there because we have another question coming from Michael, and he's wondering, there was no mention of PV or wind for use in industry, and he's curious if this is because you don't see great potential in these areas, or if it was just outside the scope of the project. And maybe just as an add-on to this question, we had several people asking if the report is available online now, so if you could share those details.
Indeed, the industry roadmap looked at only the heating part and the feedstock, so biomass feedstock for chemicals and polymers production. The potential in power generation was outside of the scope, as this was dealt with in the overall REMAP project under the power sector. So the focus was on really substituting the fossil fuel use as direct heat generation and as steam generation and hot water generation. And Ruud has shown in his presentation actually a couple of industry-related reports which we are releasing. The industry roadmap, the summary document, has already been released in June 2014, and it's online. The background paper will also be available. Any interested participant can contact us, and we are happy to share it, and it will also be available on the webpage soon. And there are also technology briefs in various areas related to the industry sector on bioethylene, biomethanol production, and recently released updated solar thermal for industrial applications is out there. But we also have a number of biomass heating applications which you can find on the web page. These are also, everything is available. And I would like to pass it to Ruud as he wants to add on to some more issues.
Yeah, I just wanted to flag one issue. In our roadmap, we mentioned kind of electrification as one of these priority areas where more can be done in the industry sector. And it essentially relates to some of the work which is done actually coincidentally by a colleague who is also called Michael, who has just released his latest costing report, which shows that especially solar PV, wind, but also hydro and geothermal power generation are cost competitive in many cases with conventional power generation. So where that is the case, of course, and where industry is relying on relatively high electricity prices to get electricity, on-site power production becomes a very interesting option, and that's what we identify with in the area of electrification. Of course, the other way to look at it, and I briefly mentioned in my presentation as well, is to locate electricity-intensive industry to areas or places where you have cheap electricity. So, for example, you could think of very windy areas where you would locate industry so that they can take advantage of the high efficiency of the wind turbines in that location. Or you could think of locating industry in an area where you have a lot of geothermal potential. So you could produce low-cost electricity, but at the same time use waste heat to provide process heat for your industrial processes. So I think there's a lot of combinations possible, and yeah, like we said, we are at the frontier, so there's a lot of things which still can be happening.
Thanks very much, Ruud and Degar. So we only have time for one more question, unfortunately. So this question will go to Linus. We have Abdul Karim wondering if you think that there is potential to exploit solar thermal in industry within Nigeria, and if there's anything that UNECA is doing to popularize the use of solar thermal and other renewable energy technologies in Nigeria currently. So Linus, you have the floor.
Indeed, there's a lot of potential, not only in Nigeria, but in other African countries where you can use solar thermal for drying, especially in the agricultural sector. So you can increase crop values. You can increase, Nigeria produces palm oil, it produces cocoa, it produces all kinds of things, and all of these could benefit quite strongly from solar thermal applications. So the potential is huge, not only in Nigeria, but everywhere. And as I said in my presentation, we've seen the framework that is done. We now need to do this more focused on Africa. You saw from the REMA presentation that we only had Morocco, Nigeria, and South Africa. And so UNECA wants now to work with IRENA to have more detailed studies for the countries so that we can best identify these opportunities and promote investments in them, and therefore increase the use of renewables, solar heating and others in for productive uses and in industry, and indeed for power generation. And of course, you're welcome to send an email, and we can discuss more about what UNECA is wanting to do in the different countries and the different regions in Africa.
Wonderful. Thank you so much, Linus. So unfortunately, we've run short of time for questions. I know many of them weren't answered. So please do join the discussion on the IRENA community if your question wasn't addressed today. I'm sure all of our speakers will be happy to get back to you. So I'd like to share a big thank you with our presenters today. I think you provided great insights on the topic, and a big thank you to all of our participants who joined us. So before we conclude the session, we'd like to ask that you participate in a very quick poll to help us improve our webinar series. So you will see 3 questions pop up on your screen, and just please select your answer. So we will launch the poll now. Great, thank you so much for your feedback. And lastly, we'd like to invite you to connect with IRENA on social media. So you can follow us on Facebook, on Twitter, on YouTube, where you'll find the recording of today's webinar as well as other archived webinars. Join us on the IRENA community and on LinkedIn. So a big thank you again to all of our panelists and for our participants for joining us. I hope you all have a great day.